Hey, 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 it is time again for Astronomy Daily Live. So hey everybody, hope everybody's doing well. Yeah, everything's good here. Back from a short one day hiatus from the live stream to now I don't know why that happened. That's a little weird. I just tweeted and the the text and the link went out, but the image did not. The image stayed in a separate tweet. So go figure that one. I'm gonna tweet again here because I want my little picture in there. Dang, it's trying. It's giving me the finger. There we go. There we go. All right, let me get over here and kill this before it kills my Linux machine. All right, very cool. So yeah, I hope everybody's doing well. Yeah, the gig last night went well. Um, we we were going to do four songs. We were going to do three of Danny's and one of mine, and we ended up doing two of Danny's and one of mine. Um, and I guess I mean, look, it was a very small crowd. I mean, so pitiful in terms of of that, right? But I guess there were two or three times as many who normally uh, um, go to those things. So in I mean, it's statistics, right? I mean, it's statistics. And with statistics, you can manipulate things any way you want. You can make it look really bad. You can make it look really good, or anything in between. so, so yeah. And look, as a scientist, right? As a scientist, I try to look at things from as many angles as I possibly can. Maybe that's not a typical scientist. I don't know, but so on the one hand, from one perspective, it was a pitifully small crowd. I mean, sad, right? Sad. Um, but looked at it in a different way, it was two or three times as many who normally attend, and that's pretty significant. So yeah, it really, you know, depends. I do exactly the same thing um, with this live stream, right? The um, uh, I guess the idea or one of the definitions of success is uh, if you take the number of subscribers and multiply that by zero point 0.1, so 10%, if if you can pull in that many views for each video you do, if you can pull in 10% of your subscribers as views, then you're doing really, you're very successful, right? Um, Now, 10% of my viewers is 9.3 uh, views per video. And let's see, in the past 28 days, I have pulled in 605 views. So 605 every, and I guess I haven't said this enough. I should pull over the chat so I can see what kind of frivolity is going on over there. Uh, and I should say this much more often than I do. Okay, every good scientist has within their reach, within arm's reach, right? Arm's reach, especially when they're working, especially when they're working, every good scientist has an actual physical calculator within hand's reach. Every good scientist does. So 605 divided by 28 days is 21.6 per day. And if I divide that by my number of subscribers, which is 93, then I'm pulling in 23.23%. So, um, given the 10% rule, I'm being extremely successful, right? Now, in terms of actual views in the past 28 days, 605 views. That's greatly appreciated. But relatively speaking, that's pitiful, right? That is downright non-existent, right? So, I mean, most of the channels that I uh, watch um, get 605 views in the first hour or two, or at longest uh, the first week or day. So to have 605 views in 28 days, that's pitiful, right? But if you look at it in terms of percentage of subscribers, that's really incredible. That's really incredible. Now, um, I'm not doing this primarily for subscribers and views and all of that. That's not my thing. You know, um, Bucky Fuller had this really cool term called what did he call it? Oh man, I'm forgetting. But um, it's essentially the concept of side effects, right? Um, and you know you have this sort of this primary thing that happens, and but right, all these other things happen as as well. And oh man, I'm trying to remember what he called that. Ephemeralization is not the term. Ephemeralization is doing more and more and more with less and less and less. But oh man, he had a specific term. Um, anyway, as I said, it's the concept of side effects, and my primary uh, goal here with this live stream is is to share a passion, is to share a passion, um, and that passion is um, having having fun thinking about astronomical things. And I, you know, if I could give everything I have um, away, I would. So I mean, I like to give and give and give and give. Um, but when you don't have things to give, it's hard, right? But the things that I do have, I am more than happy, you know, to give away. I think, I mean, that's how the universe operates. Do you think that do you think that the sun concerns itself with getting something back for all it's giving? I don't think it's concerned about that at all, and neither am I. Neither am I. I, but um, I think there are side effects. So, you know, the universe is also, you know, like this mirror, right? And when you throw things out, one of the side effects of that is getting stuff back. That just happens. That just happens. And you don't even have to worry about it. It's just going to happen. So things like subscribers and views and possible, some kind of future um, support for my work. Um, I that will likely just happen, and I'm not worried. I'm That's not my focus. My focus is um, sharing the passion in a fun way, right? Just having a blast, right? I mean, being serious, or at least being sincere, but having a fun time, and not having to rush, and not having to try to pack a lot of information in, not trying to teach you anything at all. Um, but all those things will happen. They'll just happen. So I wish I could remember that term. I'm so tempted to dive into one of Bucky's books to see if I can find it, but now that probably wouldn't that probably wouldn't happen in any rapid kind of way. So yeah, we're just here to have fun. I'm calling this the circle of friends who, we get together on sort of a virtual porch, right, with our lounge chair, which are the most comfortable lounge chairs, right, padded ones, and it's you know uh, I sort of envision, sort of right after sunset, right? And the sky is getting darker, and it's completely clear, right? I mean, being down here in southeastern Arizona, I don't have to imagine these kinds of things. These kinds of things that I'm describing to you is a common occurrence, right? Very, very common occurrence. I mean, tonight is definitely going to be one of those that I'm going to describe, right? So the sun has just set, right? And we're sitting out on a awning covered porch, right? Sort of a concrete slab, right? And we're sitting in our lounge chairs, and we have our any, whatever your consumable is, right? Enjoy, sit back and enjoy. Cheers. This is hydrogen hydroxide, HOH, one of the most amazing molecules in the universe. Incredible. Cheers. Mm, fresh batch. Fresh batch, too. But so, the sky now is going to get slowly darker, right? And there's a quietness. There's a quietness that um, sort of envelops things at this time of day when all that energy from the sun is now blocked, right? And it's all you're getting is scattered light. It's just scattered light. And the earth is rotating, which, you know I swear sometimes it seems like I can feel that, right? There's a little bit of a force that's sort of a little bit of a torque, right? It's probably I'm just making it up, but um, and it's getting darker and darker, right? And the stars are starting to pop out, and here we are, right? Sitting in that virtual environment, um, and we're talking astronomy, right? For just a little while every day, right? I greatly respect your time, and I don't have really any desire, to go more than about an hour or so. Now I could talk astronomy all day and all night, and I have, um, and I'm pretty much thinking astronomy most of at least my waking time, something astronomical. Um, but this is extra fun because it's sort of like a discipline, right? I mean, but it's also a practice, right? So that's sort of a secondary thing. Is that number one above all, share the passion. That's what it's all about. um, about this particular subject, right? And it's a little broad, right? Because I like to talk about science in general, as as well as this amazing tool that we've created that allows us to experience and see things that you may not usually see and experience. So anyway, so that is the number one thing. But number two for sure is just getting better and better and better. Right? It's a practice, and my goal there is to just get better and better and better. I mean, and end up being really, really, really good. I mean, really, just uh, just absolutely mind blowing at this, right? So yeah, it's something to aspire to and something to have fun with, and it's almost, I mean, it's killing a lot of birds with one stone, as they say. Um, so yeah, yeah, glad you could come here and be on this journey with me because this is just a curiosity thing, right? As a scientist, I'm extremely curious, I'm extremely skeptical, and I'm extremely open-minded. So I combine those things into one, and it's really intense, right? I mean, it's seriously intense having those three um, strong motivators there simultaneously, right? It's really, really great. Anyway, happy June, everybody. It is now, uh, in terms of UT time, it is the 2nd of June at 2:17 UTC. So happy, happy, happy June. We are into June, and we have 3 weeks until the Northern Hemisphere summer solstice, which gotta say, I think is my favorite one. I think it's sort of an arbitrary choice, right? Because I like them all. Those four events, right? Those four events, the two solstices and the two equinoxes, are events that the entire planet experiences. Doesn't matter what you are, right? You can be a rock, you can be a tree, you can be a rhinoceros, you can be a um, uh, well, yeah, you can. That even extends a little out into space, right? So, I mean, being somebody on the International Space Station, yeah, yeah, yep, you're experiencing the Earth solstice. Um, so yeah, and one of the interesting things, right, about these events that actually occur, as opposed to a lot of the holidays, um, where they're not necessarily tied, specifically to uh, things happening. I mean, there's lots of stories, but um, you know, these are actual events, that happen, right? And so yeah, the summer solstice in the northern hemisphere is the point in time, right? It's a point in time um, when the sun is at its highest declination. It's the highest above the celestial equator that it will be uh, uh, this year, right? And of course, the path of the sun along the sky is what's called the ecliptic, and it's angled. It's angled 23 and a half. degrees to the celestial equator. Is that right? Yeah, that's right. That's right. Um, and that line is actually the path of the sun. Um, if you want to look at it that way, this it's actually the Earth revolving around the sun, and as we revolve around the sun, um, we get to look at different patches of the sky. And in fact, we're going to look at something like that tonight. Is there nobody in chat, or am I just not seeing it? Because it looks like I have viewers, but I'm not seeing any chit chat. So I think what I'm going to do is I'm going to go back over to here, and I'm going to pull the chat up again, because I'm not convinced that there's nobody chatting, although that's entirely possible. But usually I've got a pretty lively little crowd here. So I'm going to pause that so it doesn't kill my Linux machine, and then I have to wait because my bandwidth is so low. Cha-ching, 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 cha-ching. Wow. And I'm taking up so much. All right, you're just being quiet. All right, I'm going to. You guys, uh, you guys constantly surprise me with your behavior, which I greatly appreciate. Cool. Okay. um. Anyway, yeah, it's almost the solstice, and uh, yeah, um, I think that's Tom. I think that's what holidays, holy days, right? What holidays should do is they should sort of, make you think differently about things, because things do change, right? They do change. That's the nature of the universe, is change. In fact, what I've observed and what I say is that change is changing. So how things changes. So I'm talking mathematically, right? I'm talking about the second derivative of 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 things happening, right? The the zeroth derivative is something happening, right? Now, if something happening was constant, then the same thing would happen over and over and over again, right? So the first derivative of something happening is what we call change, right? Um, and so when your first derivative is constant, then you have constant change, right? So things are happening, but they're changing constantly, right? You with me? See, I mean, being a mathematician, this is how I think, right? Um, but my observation about life and the universe, right, is that we're actually experiencing the second derivative of things happening. So um, what I say is that the change is changing. Yeah, and you know, uh, just like in mathematics, uh, all these things are following a function of some sort. So um, I'm not sure I'm not sure if the second derivative is constant or not. I'm sort of thinking that the second derivative probably isn't constant, and that maybe we're experiencing third derivative change. Um, so just to put this in sort of getting back to physics a little bit, right? Um, the analogy to what I've just been talking about is the various kinds of position, right? So position is a zeroth derivative um, value, right? So if you measure the first um, derivative of position, what you get is velocity, right? Because that's how much your position changes as a function of time. And if you have a constant um, velocity, then your position is constantly changing, right? There's that word again, though. Um, so, but the um, the second derivative of position, which is the first derivative of velocity, is acceleration, right? And if acceleration is constant, then your velocity is constantly increasing, right? You're accelerating, right? Now you can have, well, yeah, I mean, if it's constant, then you don't have, um, uh, well, you may have, positive constant acceleration. You might have negative, right? But I mean, it's flat, it's constant. But the third derivative of position, which is the second derivative of velocity and the first derivative of acceleration, I forget what these terms are. Let me. I didn't mean to go down this road, but it's kind of interesting. I'm gonna Google the term derivatives. Um, actually, derivatives of position, because these things actually have names of position. Derivatives of displacement, they call it. So yeah, third um, derivative is technically called jerk. Fourth derivative is called jounce. But jerk to me is like a bump, right? So when you're going down the road and you feel a bump, right? That's your acceleration changing. So I mean, uh, So yeah, I mean, who knows really what the end to that is? And in fact, one of the interesting things that I have done in the past, and maybe I should pull that out since it's the weekend. I've got a little extra time. Um, I make these interesting plots that actually, again, it's with Jupiter's four Galilean moons. But what I do is I actually compute the the well, I get the position right the JPL Horizons website, and from the position, I can measure the velocity, I can measure the acceleration, I can measure the 20th derivative if I want to. And the interesting thing is that there are some really, really interesting things that start happening around the fifth or sixth derivative of position. that I'm going to have to remind myself exactly what those are. Once you get into the fifth or sixth derivative of position, you're more or less running into the wall of um, significant digits. So these calculations are done, and I mean the JPL Horizons website, although they rely on uh, very 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 good models. It is you know fundamentally mathematically based, and at some point you you run into this wall of precision, and and instead of starting well instead of continuing to see interesting patterns in these higher derivatives, what you start seeing is patterns um, in the processing of computing these numbers. So you can't be too confused about those. But the third and fourth and fifth derivatives are pretty interesting. Are pretty interesting. I need to. I can pull a few of those out because that. I mean, I guess if you've never thought about it, uh, uh, which I don't think a lot of people do, um, maybe these concepts are a little bit confusing, but I'll show you some pictures because look, this is not demeaning in any way at all, but little children um, start by looking at pictures, right? That's how we start to learn. That's how we start putting things together, is looking at um, pictures, and that's my go-to thing, right? I mean, if I don't understand stuff, I want to try to see what I'm trying to understand, or see or hear or something, right? In order to get a grasp of it. So I'll make some plots, and we will cover these kinds of things. But as I said, I think these kinds of mathematical concepts can be extended a little bit into sort of everyday life experiences like change, and the fact that change changes, and maybe that changes. Don't know. We don't know how far into all that it actually goes. And just as an aside, um, um, derivatives are nothing more than sort of fancy differences. So that's all a derivative is is a measurement of difference. It's honest. It's fancy subtraction. It's fancy subtraction. An integral, right, which is another calculus term, is nothing more than fancy adding. That's all it is. It's all it is. If they would have told me that derivatives and um, integrals are fancy subtracting and fancy adding when I got into calculus, I don't know if it I, I don't know if it would have stuck back then, but I I wish that I would have understood that then, because math is hard. Math is really hard. Um, but I realized, you know, maybe 10 years ago, right, that 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 calculus is nothing more than fancy adding and fancy subtracting. That's all it is. Curse them all. All right. Well, since it's the first part of June, I thought that we could go over to cloudy nights again. Oh, I got to share my screen and look and see what's happening this month up in the sky. Let's. Uh, my my intention tonight was to keep it a little bit light, but I guess we went a little heavy there. Um, and I want to pull up my smartphone now so I can see I can see that my live stream is going here. I should try to monitor that. Okay, so this is Cloudy Nights, which is a great, great, great site. I mean, if you want to get into astronomy at sort of the amateur level and advanced amateur level, this is your site. This is an awesome, awesome, awesome site. Very, very active. Nice people, really, really nice, intelligent. Okay. Um, yeah, yeah, and this forum is really for everybody. I mean, if you're new, um, you are welcomed, right, and helped. And if you're experienced and serious, then you get feedback, right? It's great. It's really, really great. So every single month, this guy Dave Mitski, who I don't know at all, that's just what it says here, um, puts out this really, really, really decent calendar. Now, there's lots of astronomical calendars that, may or may not show you everything, but there's a lot of things that I sort of appreciate about about this, and that is, one, all times, unless otherwise noted, are universal time. So I appreciate that because that tells me that this guy realizes that there is one time, and that is right now, and we've decided arbitrarily, I mean, there was probably some kind of, political influence. There's probably, some kind of deal made, in the back room, where, it was decided that, okay, this longitude right here, we're going to call 0, um, um, 0 degrees, 0 hours, right? This is our prime meridian, and arbitrarily chosen. It doesn't matter what it is. It just doesn't matter, right? What matters is that we are right here and right now, and we call that time universal time, UTC, coordinated universal time. So there is only one time. So I appreciate that, right? The other thing, I guess, is that there's a lot of information here. He packs a lot of data into a very, very small space, and I appreciate that too. Cheers. So let's go through this now. I I started going through this prior to the live stream and got completely distracted, and I'm going to do exactly the same thing here. So we probably won't get through all of this because, let's face it, this is a really great platform for us to talk about, sort of just some basic astronomical concepts. What can you see pretty much, without a telescope, without binoculars, even just I mean, what events are taking place um, uh, in sort of the local area, right? You know, the solar system, right? The moon and the planets, the asteroids. What are they up to, right? And that's about it. And what that does, right? I mean, it allows us to talk about all these things, but I think that it really helps, um, especially um, um, newcomers, but also the oldies, um, to sort of get wrap their head around what what exactly our position is in this place, and allows a perspective that you know, most people don't have. I mean, you know, I was going to say this earlier. You know, who who is really aware that the summer solstice is happening at 10:08 UTC on the 21st of June, right? I mean, really, who cares, right? It, it it's a moment, and you know, most people don't don't care, and it doesn't matter all that much, and that's absolutely true. It doesn't, but I mean, um, for me, it's an event, right? And as I also said, you know, it's sort of a shared experience, whether you're you're aware of it or not. But anyway, so let's start going through this. So uh, we missed yesterday, um, but it looks like um, this thing that says Mercury is at the ascending node. That just means that it has crossed the celestial equator and is moving north, right? So its declination is now positive as opposed to negative, right? And so there's that happened yesterday at 18 hours, right? So today the moon is at apogee. Now apogee is the furthest away that the moon is going to be in its so-called orbit around the Earth, furthest away, right? And he even says um, how large it looks, right? 29 arc minutes and 29 arc seconds in diameter, right? And he says how far away it is, so we can see that the furthest away it is about 250,000 miles or so. Now, interestingly enough, Io, uh, its furthest distance, its apogee, as it's called. See the G here is sort of geo, right, for Earth, and Jove is Jupiter, right? So Eo's um, um, apogee is about 420,000 kilometers. So it's pretty close to to the moon, right? So the distance between Io and Jupiter, and that is their centers, is about the same as between the Earth and the moon. So I thought that was kind of interesting. So anyway, that's happening today, a little bit later. What, in about 13 hours and 50 minutes from now, the moon is going to be the furthest away from Earth as it's going to get this time around. Now the apogee, that happens every month, right? Every time the moon goes around the Earth, it's not a perfect circle. Um, um, it's an ellipse that that's also sort of wobbling around. So yeah, lots of interesting motions there. Um, so tomorrow, Mercury gets pretty close to um, Aldebaran, and the moon is close to Mars, and the moon is now in descending node. So descending node is the opposite of the um, ascending node, and that is it is crossing the celestial equator, 0 degrees declination, and moving south. It's moving south. Let's see. On the 5th, Venus is 8.1 degrees from um, Castor. I don't find that extremely exciting. Um, that's not very close. Um, here's the one that stopped me before, and yes, I think um, we are going to go elsewhere after this. So at 2 hours UTC on the 6th, Mercury is going to be what is called at superior conjunction, and that is when Mercury is almost exactly between the Earth and no, sorry about that. It's when Mercury is on almost exactly the other side of the sun from Earth. That's why it's called superior, as opposed to inferior conjunction. Inferior conjunction is when the moon is almost exactly between the Earth and the sun. Right, that's a conjunction as well. But we also have this um, superior conjunction, which is when the the planet Mercury is on the other side of the sun from Earth, and it just so happens that um, we can see that. We can actually see that happening. The other interesting thing is that I didn't know this, but Mercury on the same day, right, 6 hours later, 6 hours after superior conjunction, Mercury is also at perihelion. A perihelion is when the the object is closest to the sun, right? So Mercury is going to be less than a third of an astronomical unit away from the sun and 1.322 astronomical units from the Earth. Now, does that make sense? I think it does, right? Because the Earth is about 1 astronomical unit from the sun, more or less. I guess this is June, so we're actually at, oh, you know what? The Earth, the Earth itself is almost at aphelion. Wow, when does that happen? That happens really soon, doesn't it? Why doesn't it say here? Doesn't that happen in June? It doesn't say. I think we're furthest away from the sun sometime in June. Isn't that right? I'm looking. I'm not seeing anything about that. He couldn't possibly have missed that. No way. Absolutely no way. Huh. Well, I guess I'm not going to linger on it too much. But wow, that's a little weird. That's a little weird that it isn't listed there. Maybe I'm just not seeing it. Moon at perigee. Greatest declination north. Moon is. I'm looking at all the other entries frantically here. Wow, I'm just not seeing it. Huh. All right. Well, we'll, we'll figure that out. Anyway, um, the Earth is very, very near perihelion, so it's the furthest or aphelion. Sorry, aphelion. That's the furthest away that the Earth is going to get from the sun. Sorry about that. So we're greater than 1 astronomical unit away, and Mercury is on exactly the other side of the sun from us, um, and it's actually the closest it's going to get to the sun. So you can see there's a little bit of difference here. 1.322. Well, let's pull out the calculator here. 1.322 minus 0.3075. So that's 1.0145. So that's about how far away we are from the sun, is 1.0145 astronomical units. Interesting. Anyway, so these conjunctions of Mercury and Venus, right, the inner planets, well, also the outer ones, but in a different way. The outer planets only have superior conjunctions, right? Because since they're further out than the Earth, we can only see them behind the sun, right? But with Mercury and Venus, right, they are closer to the sun than the Earth. So we can actually see them in conjunction with the sun twice, right? Um, inferior conjunction, as I said, is when the planet is between the Earth and the sun, and superior conjunction when the planet is on the other side of the sun. So Mercury is going through a superior conjunction right now, and we can actually see this happening. So we're going over to the Soho site, which I don't think we've ever been over to the Soho site, which is not necessarily a shame, but yeah, okay. Oh, okay. It's in July. Okay, all right. I thought it was June, but what do I know? Yeah, July sounds about right. Okay, so we're not quite at aphelion yet. We have another month or so. Okay, thank you, Uncle Bill. Appreciate the support that Uncle Bill always gives. He's a ninja too, right? I mean, he's probably helping and supporting at least 20 live streams right now. That's all I can say. So one of the instruments on Soho are these LASCO um, devices, which are coronagraphs. They block the light of the sun. Well, yeah, I'm going to load this and I'll talk about it at the same time while it's loading. So here's where they've sort of blocked the light from the sun, and you can sort of see that there's a thing in here, that's holding it in place. But what it does is it allows us to see, sort of interesting structures um, around the sun that we wouldn't normally see because the sun's so bright, right? And these cameras are sensitive enough that they can actually see at least some of the brighter background stars, right? And look, right now, right, you can see, this is the UT date and time, but right now you can see the Hyades. So this is um, Aldebaran, and you can see the Hyades right there. So right now, the sun obviously is going through Taurus. Now, as you're looking, do you see this bright spot over here that is coming in from the right? Well, that's Mercury. That is Mercury. And in 6 days, right, or 5 more days, 3 more days, whatever it is, um, Mercury is slowly gonna move, and you can see this. I mean, you can see motion here. These pictures, right, are running. It looks like about every 15 minutes or so, right? So with 15 minutes of motion or of time, you can see Mercury moving. So it's moving fast, right? So in 3 days, it's going to pass right behind the sun, right behind the sun. And the cool thing is about this is that we actually have two LASCO views. Let me pull up the other one here. Um, we have this wide field one, which is the blue one, and we also have this narrower field one, a little higher resolution as well, and you can sort of see its field of view there, right? So this white circle here would be the disk of the sun, right? There it is. So now this GIF movie has loaded, so you can sort of watch the whole thing go. And you can see how incredibly noisy it is, right? These are cosmic rays, electrical events, whatever, right? But you can see that the Hyades are slowly moving through this field of view, and Mercury is over here. Isn't that cool? I think it's awesome. So I'm pretty sure that over the next few days, Mercury is definitely going to be going at least into this field of view, right? It might pass right behind the sun. That will be very, very interesting. That's pretty rare. That's pretty rare. Usually, Mercury's up here or down there, moving across. But this time, it's wow, it's on a collision course. So that's pretty cool. But it's really, really neat to see the Hyades. And uh, actually, astronomers uh, are able to take this photometric data and turn it into some pretty accurate science. I think they can watch variable stars here. All kinds of other things they're doing with this data. You're watching classic Doctor Who? Very cool. I had no idea. It's it it's going to be on Twitch for the next 7 weeks. Holy moly. I um and um sorry to offend, but the new Doctor Who, at least in my opinion, is terrible. It's absolutely awful. Um I've tried to watch a few of the episodes and I can barely make it through them. Probably a horrible, horrible bias, but I like the original Doctor Who so much better. Oh, the stories are so much more interesting, and yes, 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 you have to sort of look past the low budget and all of that, but the stories are interesting. The acting is very good, right? And I mean, really, come on, who needs all the CGI and all the monsters and everything, right? I mean, let's tell a good story, right? And that's what I appreciate about the original Doctor Who. So, Uncle Bill, if you don't mind and if you can, I would greatly appreciate a link to that Twitch stream. You can put it in the Discord and or on this chat. I would greatly appreciate that because, see, now you've just um, I had plans this weekend, dude. I had plans, and now they are going to be completely disrupted because I now know that classic Doctor Who is being played on Twitch. So, yeah, it's just, oh man. And yeah, I like all the doctors, but my favorite one, I forget what the actor's name was, but it was the older guy. It was the older guy after the Penguin guy and before the really popular one, the famous one, the guy with the scarf. Okay, cool. Thank you, Uncle Bill. I'm going to open that link right now. I'm not going to watch it. I'm just going to I'm just going to uh, get over there so I know where where to look. Okay, cool. Thank you, thank you, thank you. Oh, what a dangerous thing. Anyway, I like the older guy. Uh, yeah, he that was sort of my favorite doctor. As I say, I don't remember what the name of the actor was. So yeah, plants change. See, what did I tell you? See, this is a bump, right? This is a third derivative of of things um, happening, right? So certain things happen. Third derivative. I'm feeling the Doctor Who bump. So yeah. Oh well. I'm gonna have to watch a little bit of that now. Wow, 6,300 people are watching it. Oh, Uncle Bill, I don't remember Tin Lizzy. No, it was the one right before the famous one with the scarf. Tom, somebody. Um, yeah, I'm terrible with names, so yeah, I can't be absolutely sure. Anyway, so this is Soho, and Soho is very very awesome. And as I said, yeah, I think this field of view, this smaller field of view here, is this entire field of view here. I think that's how that goes. So Mercury is definitely going to be coming into this narrower field of view, and I dare say it's probably going to be going very very close to behind the sun. So yeah, very very cool, very cool. So let's see. So that's happening. Uh, we're going to have to celebrate that on the 6th, right? Because that's happening at the moment that this live stream goes live. So on the 6th of June at 2 hours UTC, we'll have to cheer that Mercury is exactly opposite us on the other side of the sun. John Pertwee, yes, it's John Pertwee. Tom Baker, yeah, yeah. Pertwee was my favorite doctor. I thought, or I think that character of the Doctor was absolutely awesome. You know, Tom Baker was good too. I mean, all of them are really really good. Um, the first one, you know, I haven't seen a lot of that one. I've seen a few, but not very many. But he was very very good as as well. And you know, I mean, I like Sarah Jane, right? I mean, she's awesome. Uh, yeah, Doctor Who is great, especially the original, right? And I said, um, no offense, but I really do not. I I haven't found any of the new Doctor Who's, and I probably I'm sure haven't watched enough of them, right? But after the third or fourth one, it's like, oh man, I can't go through this again, right? Because I try, I really really do, but you know I can only handle so much. Yeah, and Pertwee was awesome. Yeah, he had class. He was very sophisticated and very I mean he thought that he was really hot shit, right? Yeah. All right. So okay, yeah. So Mercury superior conjunction at 2 hours UTC, perihelion 6 hours later or 8 hours later, right? Very very cool. um Venus there, last quarter moon on the 7th. Yeah, you know, the Curtis cross is a pretty cool looking um, object on the moon. Kind of cool looking. Um, so interesting on the 9th of June at 4 hours UTC, Mars and Saturn are at heliocentric conjunction. So that just means that you can draw a line, a straight line from the sun through Mars to Saturn, right? They're all lined up. That's what heliocentric conjunction happens. On Earth, we would call that, well, if you, yeah, and maybe this is an interesting perspective, right? Um, if you're standing on Mars, then Saturn is at um, opposition, right? And if you're standing on Saturn, Mars is at superior inferior conjunction, right? So yeah, two two different things because you know the perspectives are different, right? So that's kind of cool, you know that he mentions that. Um, so the moon is doing its thing. You know, it's that happens all the time. So yeah, the equation of time, right? The mean solar time versus the apparent solar time is exactly zero, right? So on the 13th of June at 4 hours UTC, the equation of time is, well, it passes through a 0 point, right? Um, you know, coincidentally, right, we're really really close to the um, to the solstice, right? Makes total sense. Total sense. Um, Earliest sunrise at latitude 40 degrees occurs on the 14th. Very cool. Um, so you can see that the moon is now. Let's see where is that? Got lost. Um, well, where did I see that? There it is. So yeah, on the 14th also, right, the moon is at perigee, right? So that's the closest it's going to get to Earth in this orbit. And as you can see, 223,000 miles versus 251,000 miles. So, I mean, there's a difference there of 50,000 miles. That's not insignificant, right? That's quite a bit of difference, and it shows up for us in that the size of the moon gets bigger, right? It's getting closer, so it's bigger. That's how those things go. All right, well, cool. Well, you know what? I think for now, let's call this an end. I'm gonna stop sharing. I'm gonna come back over here and take one more gulp of this wonderful chemical. Cheers. Very, very cool. Yeah. Very, very nice. Well, I look forward to Doctor Who now. Yeah. Very, very cool. I think we're going to sit back and watch that the rest of the night for sure. For sure. Okay. All right. Well, peace, cheers, and all of that. Glad you could stop in to the Circle of Friends. Do this every single day at 2 hours UTC, with some exceptions, some rare exceptions. Great to be back. I look forward to these. These are fun, and no effort at all. I mean, there's no sense of burnout whatsoever. And let's see, I started this in January. I started this like January 14th or so. So that's February, March, April, May, June. So coming up on uh, the start of the sixth month of this thing. I'm not keeping track. I don't care. That's another side effect that uh, um, uh, the library of live streams will accumulate, and that just happens as a matter of fact. So, all right, I'm gonna get out of here. Cheers, peace. I'm gonna go watch some Doctor Who, and thanks, Uncle Bill. Thank you, thank you, thank you. And I will see you again in a little less than 23 hours from now on the spin. Don't get dizzy. It's a smooth ride. Enjoy, enjoy the spin, and I will see you. I'll see you here again tomorrow. All right, peace, cheers, and all that. Bye.